Okay, we're going to learn about the moon today. So I had kind of thought we would have about 2 weeks per section, but these sections are actually a little bit shorter. So we'll probably move through them quicker than every 2 weeks. It'll probably be more like every week to every week and a half. So, which is a good thing. We're moving through it at a quicker pace than I had anticipated, which is good. All right, so let's talk about the moon. Let me put this in the presentation mode quick. And I'll go ahead and talk about this. There's also a few different pictures and diagrams I want to show you guys, and a little YouTube video that explains solar eclipses and lunar eclipses really well, so I'll incorporate that in here also. All right, the moon. It is called the Earth's natural satellite because it is constantly moving with the Earth, and we'll see that in just a second here. All right, the part of the moon that we see at night changes from day to day. The moon also changes its position in the sky. Sometimes we don't see the moon at all. So if you were to go outside on a really bright sunny day, sometimes you can see like a part of the moon. It's kind of like it almost looks like a cloud color. It's like a whitish gray. But most of the time during the day, we cannot see the moon. All right, so as the moon turns, the moon rotates and revolves in the same amount of time, 27.3 days. So almost a month, not quite a month, but almost. This causes us to only see one side of the moon. We can see the surface of the moon because the light-colored rocks that reflect the sun's light. So the moon is, as you guys all know, is kind of like a grayish white color, and it looks like it's glowing in the night sky. It's super bright, and that's because it's actually reflecting the sun's light. At all times, half of the moon is dark and half is light. That's why when people refer to the dark side of the moon, they're referring to like the back of the moon, the part that's not lit up that we can't see. And again, the moon doesn't produce its own light, it's only reflecting the sun's light. As the moon revolves around the Earth, we can see different portions of that lighted side. All right, these are the phases of the moon. These can be kind of confusing, so I'm going to try to explain it with this virtual diagram that I found, but let me read this first. The phases that occur between the new moon and the full moon are called waxing phases. So these would be considered waxing phases. The phases that occur between full moon and new moon are called waning phases. So here is our full moon right here, it looks like. These two are probably our full moons. And then these would be considered the waning phases. Let me show you guys a diagram. So this little diagram here is able to show us what each portion of the moon is called. So when the moon looks like this, the sun is only reflecting that little portion of the moon. That's called a waning crescent. To move over a little bit more, if the moon looks like this, where it's about half lit up, that's called a last quarter. This one where it's mostly lit up is a waning gibbous. There's your full moon right there. The whole thing looks like it's lit up. And then now we have our waxing gibbous, first quarter, waxing crescent, and then our new moon. New moons are always the ones that are like completely dim. So we have new moon over here, new moon over here. Right in the middle is a full moon. And then you've got waning on this side, waxing on this side. You don't need to memorize all that. I just wanted to explain it. All right, let me go back to here. All right, this is just explaining the phases a little bit more. It takes the moon 29.5 days to complete the cycle. This is called the synodic cycle. I can't talk. Synodic cycle. And I kind of showed you what the different phases of the moon look like in that diagram on the other website. This we've talked about before when we talked about ocean tides, so I'm going to skip this slide. You guys should already know this. I just left it in here for your reference, but we've already talked about how the moon phases affect the tides. Okay, so I got these slides off the internet. I've just modified them a little bit and added things, took away things, so ignore this top part here. But this is just showing you the solar and lunar eclipses. I'm going to show you a better video that I think does a better job of explaining it than this slide does. Oops. So let me just take these two pictures here and sort of describe them. So right here you have the Earth, then you've got the moon, and then you've got the sun. The reason why we have lunar and solar eclipses is because of the way the sun, moon, and Earth will line up sometimes. So this one is a solar eclipse here, this top one. And a solar eclipse happens when you have the moon going directly in front of the sun. So if you're standing on the Earth, like right here, that sun is going to be blocked out because of the moon. The moon is casting a shadow in that part of the Earth. So if you're standing right here, the moon is casting a shadow on the Earth right where you are, and that moon's going to line up directly in front of the sun. Now, if you go down to a lunar eclipse happens at night. So at night, solar eclipses happen during the day that you see anyway, and then lunar eclipses happen at night that you see anyway. So here's the moon, here's the Earth, here's the sun. The sun is always shining, right? The sun doesn't turn on and off at night and during the day. It's always on. So since the sun is shining, it's casting a shadow onto the moon. Therefore, the moon will look like it goes completely dark. It's actually kind of a reddish tinge to it because of the Earth's atmosphere. It makes the moon turn a red color. This video that I'm going to show you will explain it a little bit more. Let me go to the video quick.
A solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth. And a lunar eclipse is the opposite, when the Earth's shadow falls across the moon. Total eclipses occur within the darkest part of that shadow, the umbra. In the lighter part of the shadow, the penumbra, we get partial eclipses. So that's the short explanation. But you might wonder why we don't get eclipses every month, given that the moon orbits Earth every 29 days or so. The first reason is that the moon's orbit path is not in line with the Earth's orbit around the sun. It's tilted 5 degrees. That doesn't seem like much, but keep in mind that the model we're showing to you is way off. If the Earth and the moon are this size, the distance between them should be around 10 feet. So at this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most of the time. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its orbit, these points line up with the sun about twice a year. If the moon is between the sun and Earth at that time, we get a solar eclipse.
I'm just going to pause it right here real quick. I know this video is very technical, but this gives you a good depiction of what's happening. So here's our sun always shining. Here's the Earth. When the moon was right here on that one little node, that moon is directly like blocking out the sun, right? If you're standing right here. Obviously, if you're on the other side of the world, you're not going to see that. Only if you're standing in a particular spot. There's actually people that go around chasing solar and lunar eclipses, going to all different parts of the world to catch solar and lunar eclipses.
It's behind Earth at that time, we get a lunar eclipse. In a total solar eclipse, the moon completely covers the sun from the vantage point of some place on Earth. This is possible because, by coincidence, the sun and the moon appear to be the same size in our sky, while the sun is.
I'm going to rewind a little bit because I think this shows you
total solar eclipse,
a good idea of what this looks like. So the vantage point that you're watching this video from is like if you're on Earth. You're standing on the spot of Earth where you're able to see this solar eclipse. So what's happening is this represents the moon. The moon is coming in between the Earth, which you're standing on, and the sun, which is represented by the light bulb. So as you see, it just went dim. You can't really see the light bulb, only like the outer edge around it, which is actually called the corona. Has nothing to do with the coronavirus. Corona in Latin just means crown. It kind of makes a crown shape with the light rays.
The moon completely covers the sun from the vantage point of some place on Earth.
This is what a solar eclipse looks like. So you can see that the moon is actually directly in front of the sun. Now, it's not fully covering the sun. That's like a full solar eclipse, and those do happen. There was actually one that happened not too long ago that I got to see when I went to Liberty, and it was pretty crazy. People a little bit further south than us in like North Carolina, South Carolina, it was like completely dark for them. It was the weirdest thing because it got pretty dark, almost like, I don't know, late dusk or something like that. So it was like almost dark is what it looked like, even though it was like in the middle of the day. It was like lunchtime and it was almost completely dark out. It was the weirdest thing. But people in that specific area in like North Carolina had like a completely dark couple of minutes because they had a total eclipse for where they were standing, which is pretty crazy. Since Virginia is just a little bit north of there, we didn't get the full effect that the people in North Carolina did. But it was definitely a weird sensation.
This is possible because, by coincidence, the sun and the moon appear to be the same size in our sky. While the sun is 400 times bigger than the moon, it's also 400 times farther away. The moon has an elliptical orbit, though, so its size varies about 12% throughout the month. At its closest distance, we can get total solar eclipses, but when it's farthest away, we can get annular eclipses, where a ring of sunlight remains around the moon. In the far future, Earth will only get annular solar eclipses. We know that because Buzz Aldrin and Neil Armstrong left mirrors on the moon in 1969. Astronomers bounced lasers off those mirrors to measure the moon's distance, and that's how they found the moon is moving away from us about 1.5 inches every year. So at some point in the future, we're talking like 600 million years from now, whatever creatures live here will witness Earth's very last total solar eclipse.
They call this the diamond ring effect because it kind of looks like a ring with a diamond at the top.
Fantastic total solar eclipse taken from the pictures above the clouds.
And the odd thing is it does confuse wildlife. So animals that are nocturnal will actually start coming out because they think it's nighttime.
This is just fantastic.
The totality lasts no longer than 7.5 minutes, and although Earth gets an eclipse like this every 18 months on average, each one is only viewable by less than 0.5% of Earth's surface. Eclipse chasers will travel all over the world to put themselves in the path of that shadow. You're much more likely to see a total lunar eclipse in your lifetime. They can last an hour and 40 minutes, and they're viewable for anyone on the night side of Earth. During a total lunar eclipse, the moon often turns red. If we didn't have an atmosphere, the moon would go completely dark, but the gas molecules in our air scatter the shorter, bluer wavelengths of light, while the longer, redder wavelengths pass through to the moon. Or to put it another way, during a total lunar eclipse, the sun projects all of the world's sunsets and all of the world's sunrises onto the moon at the same time.
Pretty cool. All right, let's go back to the PowerPoint here. So for solar eclipses, the moon completely blocks out the sun or partially blocks out the sun. And this is a total eclipse. So you're getting a full blockage of the sun by the moon. This big black thing is actually the moon in between you, where you're standing on the earth, and the sun. This is what the moon will look like during a lunar eclipse. So this is when the earth is in between the sun and the moon. And as they explained in that video, the reason why it looks red is because of the Earth's atmosphere. It goes into the different wavelengths, the blue wavelengths and the longer red wavelengths, and why it looks like this red color. But it's basically projecting, like it said, all of the Earth's sunrises and sunsets onto the moon at once, which is pretty cool. All right, last slide. This slide talks about the craters and how they form on the moon. So when meteors or asteroids, comets hit its surface, it actually creates dimples or craters in the moon, which is why you have all these little divots here and it looks like it's kind of beat up. All right, that is the end of this presentation on the moon. The rest of the week we will be having activities on the moon. So just keep checking the spreadsheet on every day to see what your assignments are.